turns on.
Just turn off. Hello? Are you all good? Okay. Hey, everybody. Welcome to ACM's Intro to Docker workshop. But before we dive in a little further, I just want to cover a couple of announcements for ACM really quickly here. You know, as per usual, we have a bunch of our social media links up here, and you know, we will post on these mostly just for updates. Though I would recommend you join our Discord just so you know you have an idea of what's going on, because usually our Discord is updated the most, but we still update most of our other handles, and we're still active on them like Twitch and YouTube. But yeah, you know, I would recommend you follow us. Anyway, on the next slide. So as far as membership, so you know, so it's pretty much free. You know, the only real requirement is that you have to attend 7 meetings in our semester. I know the slide says 20, but the metric is just 7 meetings per semester. And you know, you become a member. And really, and you know, yeah, you know, you're eligible for a couple of nice benefits, like as you see here, you know, giveaways, you know, a yearly T-shirt, and so on and so forth. And as far as our upcoming events, you know, this Wednesday from 1 to 2 p.m., we have a study hall in the business building. And so basically, you know, if you need to finish anything or work on a programming assignment, you know, you can just take this hour to relax and focus on that if you so choose to. Yeah, and we also have free snacks because who doesn't love food? And so then on Thursday, we have our ACM-W meeting, and they'll be covering computer vision. And so they'll go over some basic computer vision concepts, like, you know, detecting contours and so on and so forth. And that'll be 3 to 4 p.m. and I believe the Bear Room. If that changes, we'll let you guys know. And as per usual, every Saturday we have Icpc Meetings. And for those of you who are not aware, it stands for the International Collegiate the International Collegiate Programming Contest. And basically, you know, you solve a couple of somewhat, you know, tricky programming problems that will typically involve data structures. You know, it lasts from 10 to 1, but you can drop in anytime. And as always, there's free food. But yeah, hope to see some of you guys there. And here's our sign-in link for today's meeting. You know, I'll leave it there for like a minute or two in case all of you guys need to grab that. And if you didn't catch it, or if you don't catch it soon here, I'll also post it towards the end of the meeting, or I'll show it towards the end of the meeting. So in case you didn't catch it, we'll post it back up. Everyone good? Okay. So I guess without further ado, I'll go ahead and move to our Docker workshop. And today's guest speaker is mostly going to be this gentleman aside, you know, to the right of me. His name's Joshua, and he's going to mostly lead the Docker workshop. So I'll pass it off to Joshua. Thank you. Oh, you could just turn on the back. Hello? Okay.
Thank you, Alex. Okay. So I know you guys have requested an intro to Docker workshop. So we're super excited to give you guys a Docker workshop. So hopefully you guys enjoy it and overall have a fun time. So this is our table of contents today. We're going to cover basically what DevOps is from a brief perspective. Then we're going to cover what is the basic idea of Docker, like why is Docker so popular and just why it was invented. Then we're going to cover basically some really important concepts associated with Docker, such as the Docker Hub, engine, images versus containers, hypervisors versus containers, files, Compost, and last but not least, Docker versus Kubernetes, because I know you guys are going to probably ask questions about Kubernetes. So we wanted to mention that. And also, we're going to have a really sweet demo covering what is Docker pertaining to the important commands with Docker as well. So what is DevOps? Well, DevOps is basically a methodology when teams that are associated with application development They basically come together and communicate more effectively, so that way they overall have a better flow in terms of application development. Like with the teams basically communicating with each other, the application is overall more secure, more reliable, and overall it is deployed much faster because they know what they're working on in real time. And also, in terms of the phases of DevOps, you start with the plan phase, then you go all the way to the code, build, test, deploy, operate, monitor, and then last but not least, release. And also, DevOps versus DevSecOps, because they're both trending. So DevOps is when the development and IT operations team come together to overall improve application delivery. DevSecOps is when you add security into that mix. So now it's not just the development and IT operations team. It is now the security team that you have to take into account. And overall, DevOps is when development and IT operations teams come together. DevSecOps is when you add the security element. And how Docker relates to DevOps is that you might have looked at the different stages of DevOps. Docker is in the deployment phase because I'll explain in the future slides. Docker makes it really easy to deploy your applications because of what it does and also what it is. So what is Docker? Docker is written in the Go programming language, which was invented by Google. It's short for Golang. So basically, Docker is written in the Golang programming language. But also, I talked about why is Docker so popular. It's basically a platform that you can develop, ship, and run your applications. But the main thing I want you guys to take away from this slide is containers, because that is what makes Docker Docker. Docker containers is basically a lightweight way that basically takes control of all your dependencies, such as what libraries, what operating systems, what frameworks, etc., that you need for your application, and overall package that into a container, hence the Docker containers. So that way, when this is deployed, you have everything such as your libraries, binaries, basically everything to make your application run smoothly and also deploy effectively as well. And also, Docker architecture has the 4 main parts that will be covered later in this presentation, such as the daemon, the client, the registries, and the objects. So this is the Docker architecture, starting from left to right. Your client will be basically you guys basically interacting with Docker for what you need for your application. Like, for example, you have Docker build, Docker pull, and Docker run. Docker, I will explain more about these commands in a future slide. But what these 3 main parts is basically what the Docker architecture is from a foundational perspective. So basically, the client is you guys interacting with Docker to basically tell Docker this is what I need. The Docker daemon basically is that under the hoods, like basically actually communicating with the architecture to tell Docker like, hey, this person needs a image. Okay, they ran the Docker build command. Now please do it. They ran a Docker pull command. If you've been to Alex's very cool intro to Git and GitHub intro to tech workshop, you probably heard of push and pull. So the way Docker does that is that with pull, you are pulling images or basically what you need for application from the Docker registry or Docker hub, either name is fine. And then you use push to basically push your image that you worked with to Docker hub, so that way the community can basically evaluate it and overall give you any recommendations for your application to go overall more smoothly, more effectively, that sort of thing. So basically, the 3 main parts is the client, the Docker daemon, and the registry. The registry is what stores basically everything for your application in terms of operating systems, that sort of thing. Your Docker daemon handles that under the hoods, and from the GUI perspective, the client is you guys running Docker commands to tell Docker daemon what you want. So the Docker Toolbox, this was the original way to download and install Docker before Docker Desktop. The reason why this slide is very important is because I wanted you guys to get exposed to basically the history of Docker in terms of downloading and installation phase. Now there's different operating systems with different libraries, that sort of thing, but you still need a way in order to download and install Docker in a very easy way. So the Docker Toolbox handles that when you're dealing with different operating systems. Basically, the Docker Toolbox has everything you need in terms of basically virtualization platforms, etc., to handle different operating systems, because Docker can run on different operating systems. However, the installation download phase is different for each one. So the Docker Toolbox handles that and makes sure that you have everything that you need to basically install and download Docker on any operating system very effectively and overall very easily. And However, it gave way to Docker Desktop, which is now basically the GUI version of basically installing and downloading Docker. And overall, it makes it really easy to now download and install Docker with Docker Desktop. But I just wanted to mention what the Docker Toolbox is, because it's really important to understand how the Docker Toolbox was and now how it improved to now the Docker Desktop. So what is the Docker Hub? I didn't mention it's nicknamed the Docker registry. You can name it any way that you want. You can name it Docker Hub or the Docker registry. It's the same thing. Basically, the Docker Hub acts as a repository for basically anything that you need for your application. Like, for example, if you needed a certain operating system such as Debian or Ubuntu, you'd go to the Docker Hub and basically pull that container down and basically be able to have everything that you need in one place, because the repository stores everything that you need for your application development. It's just that you need to go there and basically tell Docker that this is what I need. And also, I did mention Git. It is very similar to how you use Git in terms of push and pull. Pull is that you click on the things that you need and download and install them for Docker. Push is when you basically are done and then you push them to Docker repository for the community to overall evaluate what you did, give you guys recommendations and things like that. So I just want to reference why Docker Hub is important, and also how the Docker Hub works in terms of push and pull, that sort of thing. And then at the end of the presentation, we'll do a really sweet demo using accessing Docker Hub using WSL2. Next slide, please. It's fine. So this is what the Docker Hub is. Basically, I mentioned that it was a repository of everything you need for your application. You name it, Docker Hub has it. For example, operating systems, programming languages, databases. It has everything. So if you're curious of what Docker Hub had, this is what the Docker Hub has in terms of basically categories. And overall, it really gives you that customizability and flexibility in terms of what you need, because the Docker Hub makes sure to be not only updated, but also be able to also be added. So the Docker Hub continues to be upgraded in terms of what it already has, but also new images, etc., is always added to the Docker Hub. So if you need anything for your application development using Docker, I recommend using the Docker Hub, because you will probably see it and overall use it efficiently. So what is the Docker engine? This is very important for making sure Docker is Docker and Docker runs efficiently and overall effectively on your operating system, because this is what makes Docker run effectively. So what you can think of the Docker engine as basically the heart of Docker. Like if this isn't downloaded or installed, Docker won't run. So it is highly important that you make sure the Docker engine is downloaded and installed successfully in order to make sure that Docker runs overall effectively and overall efficiently. So you can think of Docker engine as basically the main backbone of Docker and how it works. And also, in terms of architecture, it has changed. But for the sake of this presentation, I will focus on the new architecture on the Docker engine, which I stated in the previous slide. It is similar to the three-part architecture that I mentioned previously: the Docker client, the host, and the registry. This is basically a more in-depth image of that from a more under the hood's perspective. So there's the Docker client, Docker daemon, containerd, and also the library associated with it as well. I wanted to bring this up because it is very important to understand what is happening under the hoods, and this is what the Docker engine is if you're curious of what it is under the hoods. Okay, I'm really excited to basically present this slide with you, because this is one of the most important concepts associated with Docker, knowing the difference between images versus containers. So basically, when you use Docker, you start with a Docker file that basically you make sure to have all the dependencies that you need for your application, such as the right commands, the right distros, the right libraries, that sort of thing. So that way, when you use the Docker build command, you have your image, which is basically your unchangeable file that basically includes everything that you need for your application development, and also for the next phase to create your container. So you go from the Docker file to the Docker image. The Docker image is basically a file that has everything you need to basically run your container, such as the the right distros, the right libraries, the right commands, and things like that. So that way, when you do Docker run to now change that unchangeable file to basically a running instance of an image, you now feel comfortable because you made sure to state everything that you needed in terms of libraries, dependencies, etc. in your Docker image. So when you run it to make sure you create a container is what you want, that sort of thing. And overall, I just want to, the main takeaway from this is that images is basically the file in terms of what your configuration is, that sort of thing. The container is that in a running state. I found this really sweet image because it does a really great job of depicting the 3 phases that I previously mentioned: the Docker file, the Docker image, and the Docker container itself. Everyone say hi to the whale. His name is, I forgot what his name, but I just like the Docker mascot, so everyone say hi. So basically, there's 3 parts of Docker that I want you guys to get out of this, is that there's Docker file, which basically has everything that you need that I mentioned, such as your dependencies, your libraries, your operating systems, and things like that. Then you use the Docker build to now create the actual file itself using a Docker image. Then you use the Docker run command to now create a running instance of your image with the Docker run Python. And now you have a container that has Python because you ran the Docker. We went from a file, you use Docker build to create a Docker image, then you use Docker run Python to create the container. So this is another really cool concept with Docker. It is Docker volumes. So you can think of Docker volumes as the concept, as an example of the concept of redundancy. For instance, with Docker volumes, you are not starting from scratch if you are starting a new project, because you can use the data from the containers that you used with your old project, and now it can be used for your new project. Because, for example, let's say your new project is similar to the old project you worked on in terms of an application. You don't want to start from scratch, so now with Docker volumes, you can use the you can access the file systems in the containers that you use for your old project and use that data for your new project in terms of what applications, et cetera, that you used. So overall, Docker volumes makes it really easy to not start from scratch and overall do new projects, because you're starting from something that is existing, and hopefully it is similar to what you're using in your new project and overall in terms of requirements and things like that. So with Docker volumes, it is the file systems that you mount on your Docker containers, and it allows you to use the data from those Docker containers for new applications and things like that in a very easy manner. And I just want to bring this up because redundancy is very important, and being able to not start from scratch and overall make your application go more smoothly is very important. So I want to mention Docker volumes. So with the Docker volumes, I didn't want you guys to go through like 40 pages of manual pages with Linux. For example, if you were on man, any command in Linux, you'll get like a huge manual page of basically what the command is, what the options are, etc. Well, unfortunately, with Docker commands, there's a ton of different options, etc. So to basically ease that frustration, I made sure to find an easier version to access the information that you need for your application development with Docker. So instead of using man, you use Docker volume space -- help, and it will show you basically the important commands that you'll need pertaining to that certain subject. So that way you don't have to keep scrolling through the manual pages associated with these concepts. They're all just more clean and more clear and concise if you go this route. So I highly recommend it. And the main takeaway I want you guys to get from this slide is that the important commands with Docker volumes is that it is create, inspect, ls, prune, and rm. In order to use these commands, you use the syntax such as Docker volume command. And if you wanted to learn more information about the command, use Docker volume command -- help. So this is another really cool concept, and this is why Docker came to be. So I wanted to mention this because this is what makes Docker, not just the Docker engine. So difference between hypervisors and containers, and Alex and I really have really great images in the upcoming slides detailing the difference from a visual perspective. So the main takeaway I want you guys to get from hypervisors and containers is that hypervisors virtualize the hardware that you're using on your system. For example, if you have used VirtualBox before, you probably have loaded Ubuntu into VirtualBox, and then run it, and now you have Ubuntu on your system. That is type 2 when you use a virtualization platform such as VMware Workstation or Oracle VirtualBox to load the operating system that you need for your classes and things like that. A type 1 hypervisor is a little bit different, where it directly interacts with the hardware. Instead of type 2 hypervisors, they load another operating system on your device. And also with containers, the main takeaway I want you guys to get is that what I previously mentioned, containers virtualize the OS of your system. Hypervisors virtualize the hardware of your system in terms of like the RAM, the memory, and things like that. So this is what the type 1 and type 2 hypervisors look like from a visual perspective. Like I previously mentioned, type 1 is when you're actually using bare metal. Type 2 is when you use a virtualization platform such as your hypervisor to load another operating system on your system, such as Ubuntu, Kali Linux, and things like that, using the resources in terms of hardware on your system. So that's the difference between type 1 and type 2 hypervisors. Next is hypervisors versus containers. Like I wanted to previously mention, containers is very lightweight because they virtualize the OS of your system. Type 2 hypervisors, or basically hypervisors in general, virtualize the hardware or use the hardware of your system in terms of virtualization. So hopefully I cleared the difference between hypervisors versus containers, because I really wanted to mention that. Next slide. Docker files, what I previously mentioned, the Docker files is what you use to build your images, and overall it is the first step in terms of what using Docker. For example, you go from a Docker file to a Docker image to a Docker container. So you want to make sure that in the beginning you have everything listed in terms of your dependencies, so it's your operating systems, your libraries, and things like that. So that way when you build your image, you feel comfortable because you made sure to state everything that you need in this Docker file. And if you're curious about the syntax in terms of what a Docker file follows, it is from, run, and command, whereas from is basically the distros that you need. Run is basically the commands that you want to do when this Docker file builds the image. And then last but not least, commands is the actual doing when this Docker file is converted to an image, then converted to a container. And sorry, yeah, next slide. Yeah. Docker Compost. Docker Compost is a really interesting topic associated with Docker, not just because the images is really cool. Who doesn't like octopuses? Not just because Docker Compost has it, but this makes it really easy in terms of understanding what Docker Compost is. And also the image below it is pretty cool. So what Docker Compost is that you have, so that way, if you have multiple containers, let's just say you have a Ubuntu container, a Kali Linux container, a Alpine container, you can use this to manage and run the multiple containers, and just overall makes it easy in terms of configuration, but also management as well, because different applications may need different containers with different dependencies, such as libraries, frameworks, and things like that. So with Docker Compost, you don't have to worry about that because it is built to handle multiple containers with multiple dependencies for your application. So overall, Docker Compost makes it easy to do that, and just overall, it is a really great tool to know. And the three-step process is listed here. First, you make sure to define your environment using a configuration file such as YAML, because it is a easily readable file. I know there's JSON and YAML, so whichever configuration file format you're comfortable with, please use it to define your environment. And then you define the services that make up your app, what you need in terms of your application, databases, etc. Then last but not least, how do you run it? You use Docker-Compost to run your application, and now you have an easy and overall very effective way to manage your multiple containers for your application. Another really cool image that I want to mention is Kubernetes versus Docker, because I really wanted to mention Kubernetes, not just because it is associated with Docker, but just overall it is really good to know from a conceptual level. Docker versus Kubernetes, if you have gone to an orchestra, you will probably have seen the orchestrator basically waving his wands like his things. to basically orchestrate the band to play the right notes at the right time, so that way the overall song goes from start to finish very smoothly, and overall the right notes are played at the right time. You can think of that analogy as Kubernetes is the orchestrator platform that handles and manages Docker, whereas a orchestrator would handle the band to play the right notes at the right time, so that everything goes smoothly. Kubernetes is the platform to handle containerized programs, which is the programs that was built with Docker, because Docker uses Docker containers. And also Kubernetes, if you're curious about who was created, it was created by Google, but now it is managed by the Cloud Native Computing Foundation, and they are open source. And the main thing I want you guys to get from this slide is the relationship between Docker and Kubernetes. Docker is used to create programs using containers to create containerized programs. Kubernetes is the platform to handle those containerized programs. So that's why I wanted you guys to get from this slide. And if you're curious of how Docker is similar to Kubernetes from a implementation standpoint, I did that image to the left with the multiple Docker whales is Docker Swarm, which is basically the Kubernetes version of Docker. And then you have Kubernetes on the left, which is the actual platform itself. So in terms of implementation standpoint, Docker does have its own orchestration platform, but I wanted to mention the relationship between Kubernetes and Docker as well. So if you're curious about, so if you wanted a basically a refresher of what the Docker architecture looks like, I found this really nice image that details the important concepts that I mentioned, such as the client, the host, and the registry, which you can basically have another name, which is the Docker hub. And then underneath that is what makes Docker so efficient. It uses containers, which is basically a lightweight application that has everything you need for your application in terms of your dependencies. The libraries, the operating systems, etc. So that way, and overall, it is very lightweight. Whereas VMs, it is type 1 and type 2. But in general, the main thing I want you guys to get from this slide is the Docker architecture and Docker containers as well. All right, so in the important Docker commands, I really found a really nice website for you guys to reference using Docker. It is cheat.sh. Oh, yeah.
Yeah, so just to kind of explain, so this is usually, so what cheat.sh is it's basically like a handy guide for a lot of applications, and we're going to use it to reference Docker here. And so we kind of have a nice list of commands, which I'm going to let Joshua kind of take us through them. But I just wanted to point this resource out because I think it's kind of handy as a reference, just so you don't have to search and fumble through Docker docs or the man. But yeah, I think it's useful.
Thank you, Alex. Yes. I found this really nice website because it makes it easy to basically get what you need in a easily readable format. I know manual pages is a very good resource for learning about different commands, different services, etc. with Linux. But I just wanted to bring this up because it can be used in either Windows from a website perspective, but also in Linux or Mac when you use the curl command to install curl and then install cheat.sh. So overall, I wanted to reference this because it does a really good job of helping you understand the different commands with their different options in a very clear and concise format. And overall, it is easily readable. And some of the commands that I want you guys to get from Docker is the Docker build, the Docker pull, and the Docker run, which Alex will do an example of, but Docker PS as well. So if you wanted to get information about your containers, like for example, if you wanted to know which ones was deleted, which one is taking up resources when you don't want to, which one was stopped, that sort of thing, you'd use the Docker ps --a command to get more information about your containers, because you don't want the containers to use up resources on your system without you knowing that sort of thing. So Docker ps --a really helps you get more information on your containers, such as do you want them? Do you want to remove them? Do you want to stop them? Are they running? And things like that. And also, in terms of images, you can use the Docker image command to list all your images. And overall, these commands are really, really helpful to basically getting up to speed with Docker and using it very effectively and overall efficiently as well. So I really wanted to basically detail this resource to help you guys learn the Docker commands associated with Docker. Yeah. Oh yeah, so what I previously mentioned, there's other Docker commands that I want you guys to get comfortable with and overall know, and I highly recommend using t.sh as your reference. So the really important commands that I want you guys to know is Docker create, Docker ps, and Docker start, and Docker attach. Basically, when you're doing Docker from scratch, I highly recommend getting comfortable with these commands. Docker create basically creates a container from an image. The Docker run runs the image to now become a container, whereas Docker create actually creates the container from the image. So I don't want you guys to get confused with the difference between the Docker run and the Docker create. Docker create creates a container from an image. Docker run converts an image into a runnable state, or basically a container. And then Docker ps is what you use to basically get information about your containers, because you don't want the containers to use resources on your system without you knowing. So the Docker ps is a really great command to help you guys learn more information about what is Docker using pertaining to the resources on my system. And if you wanted to get more information about different kinds of containers, you would use the --a flag. And then Docker start is to start a container. Docker attach is to attach a container. All right, so more commands that I want you guys to get comfortable with. I know this is a lot of commands, so that's why I reference cheat.sh. I highly recommend using it. So the Docker, so cheat.sh basically details these commands in a very easily format, but also it gives you information that you need without being in like 50 manual pages or things like that, because manual pages can get old if you're scrolling to find a certain flag. So in terms of commands, I highly recommend cheat.sh because it's overall a really good tool. And some more important Docker commands is Docker rm, Docker kill, Docker exe, images, and stop. If you wanted to run commands on a container the same way you would do in terms of a actual Linux system, you'd use Docker exe. But what if you're done using the container? Use the Docker rm command to delete a container. And if you didn't want the container to be running and use resources on your system, you'd use Docker kill command, and now your resources are back on your system because you stopped or deleted the container. And here's a really cool demo that we make sure to promise you guys. Hopefully you enjoy this. Hopefully you enjoy the slides. And hopefully you really enjoy the demo as well.
Right. So what I'll do for the demo here is I won't do anything too complicated, but I kind of want to show, how you just would use basic Docker commands. But before we do dive in, I do want to mention something important, at least in regards to installing Docker Desktop or configuring it, in case you have any issues. So first thing usually for Docker is you do want to make sure that you have Windows Subsystem for Linux 2.0, and so you can do that by so you'd have to go usually through either Microsoft's own website or through the App Store, I believe, on your Windows computer, and you would just find Ubuntu and install it. But also you have to go into some of your features and enable it. So I'll show you here in a sec, which I don't know if you can see that here. I'll drag it over so you can see that. But basically, you do have to enable some features in order to get the Windows for Subsystem for Linux to work. Those being Hyper-V, so the hypervisor stuff. And then if you scroll down here, I believe, sorry, I'm a little blind here. I believe yes. So you also need to enable Windows Subsystem for Linux. And I think you also have to enable the virtual machine.
Yes. Virtual machine platform.
Yeah, sorry guys. Yeah, sorry. So you do need to enable this virtual machine platform option. And then once you do, what you can do is you can basically kind of, so you can launch PowerShell, and then you can kind of check your versions. I don't want to go too deep into here because, you know, I kind of want to show you how Docker works. But I feel like it's handy to just kind of discuss some of this stuff. And once you have Windows Subsystem for Linux set up, what you do is you go to settings, and I believe this option is checked by default. So I don't think you need to mess around with that, but you do need to go into resources and then make sure you have this enabled. And keep in mind, this is if you're using Windows and you're using WSL. Now, if you're on a Mac, I don't, and if you're on a Mac or a Linux system, I don't believe you really need to change much. There's probably like 1 or 2 commands you can run, and you know, you won't need to go through much fumbling for them. But anyway, as far as so here, I'll just go ahead and get started here with the main commands. So first things first, so I already have this WSL window launched. But what I do want to do is, so we'll kind of use Docker's container here. So what we'll do here is we'll issue our first command, and you know, we're telling Docker to run, and then with the DP flag 8080, and then Docker get started. Which I might have. There we go. So let me just kind of break this down for you. So firstly, so you can actually rewrite this as merely D-P, but these are syntactically identical. But basically what that does is that it creates a container, and then it detaches it, but you're also running the service on port 80. So if I go ahead and press enter, and let's go look back at our desktop here, we notice that this container has been created, but it's also running. And so, you know, so yeah. And what you can do is you can use this option to take a look at some of the stats here through the browser, but you can also look at through the command line terminal. And so let me just show you. I have this dragged on my other screen. Which, yeah, so basically, this is your container, and within that container, you are running an Ubuntu. I believe the get started image, but basically, you're running the get started Docker image inside of this container. And so I believe the get started image is, I think, some version of Ubuntu, I think. And so, you know, so basically, you're kind of in like this environment, and so, you know, we can run a couple of, you know, typical Linux commands, like for example, ls. We can see that, you know, we have right now we're in the root directory, and then we have all of our typical directories here. We can also do some other stuff, like for example, just for fun, maybe I want to make like a sequence of numbers, and then we go through every other number up to 20, and then maybe we'll just append it or create, you know, we'll append it to a file called cat.txt, and then, you know, maybe I want to see the output of this file, so. And then, so yeah, now we know that our file has the numbers we just executed through the command. So this is just kind of a basic example of us sort of going through inside of the container, right? And inside of this container, and then we're just kind of, you know, executing commands. Now remember, the most important part here is that this is like the image is like the template we are, you know, running this container off of. Like that is, you know, I think that's one of the really the crucial concepts of Docker. But before I move on to doing any other commands, does anybody here have any questions so far? We're all good? Okay. I'll probably review a couple of chat questions when we're closer to the end here. But what I'll do for now is I'll just go ahead and exit this container. And then but what I will do is I will kind of refer back to some of our commands. Like, so let's say we want to list all of our containers. So we do ps-a, and then so we can see that we have these 2 containers, right? So obviously this one is still kind of running, and this one, you know, so this get started one is still running, and then this one you notice that I've created 2 hours ago, but it's exited. So you can obviously see that the Docker desktop reflects that, and so, you know, what if I want to, you know, look at more information about this, you know, the container we're currently running? So what we would do is we would Docker inspect, and then the name of our container is Youthful Swanson, for some reason. And so when we do Docker inspect, so basically this gives us all the information about the Docker container. And so, or I believe it's image, but basically this gives us all the information in this JSON format. And now you could read through this, though I'm pretty sure for most of you, this would be kind of cumbersome to pick through this, which is why, why we mentioned that Docker files are so powerful. We could kind of simplify all of this in this nice format that's a bit more readable, rather than having to comb through all these fields like this. So now let's say, I've already done some others. So just for fun here, what I'm going to do is, so let's say we're done using this container. So what I'll do here is we'll go ahead and kill our container that's currently running. And then let's take a look at our list here. So all containers. And then you can see that right here, it tells us that we've exited 4 seconds ago. And now how about let's say we want to start another container, and I have it up here somewhere. So let's say we want to start another container, right? And let's say so let's say we want to run another container. So and I want to show you something. So I want to show you what happens if you run a container that you don't, I believe that's how you spell it. I want to show you what happens if you have a container that you haven't installed, or some image you haven't installed. So in my case, I'll go ahead and use Alpine. And then basically what I'll do, what this command is telling you is you're going to use Docker to run inside of a terminal interface. And so once you exit this terminal, or once you exit the Docker terminal, it doesn't actually exit this one. But I'll run using an Alpine image, and then I will run bin bash. So if we do that, so yeah, because I don't actually have Alpine locally on my computer, it'll go to the Docker hub, and then it'll actually pull that image from the Docker hub. And now I actually do want to note something. As far as the Docker hub, you don't actually need an account to pull images. So if you want an Ubuntu image, or maybe you want a Debian image, you don't actually have to create an account to pull those images. It's only when you're creating new images for other people to use, that's really when you have to create an account. But otherwise, you can pull them. Let me try Debian here as a better example. I think that should work. I believe. So just as an example here. So obviously I told it to use a Debian image. And so now what it is doing, it is pulling that image from the Docker hub and it is installing. And so once it's installed, because, it's already pulled it and I've told it to run inside of the terminal, I now have this, now I have this Debian, this container with Debian in it currently running. And if we look back at our Docker desktop, so this was actually the one with our error, my bad. So this is the one with our error right here. This is the one that's actually running right now. So, again, typical Unix commands, you can do ls, maybe let's go to the home directory, and so on and so forth. So I'll just exit this container for now. And so obviously you could see that it didn't actually exit this WSL container right away. Now, what I do want to do is I also want to show you the exec command for Docker. And so what I can do here is I can say Docker exec, and actually I don't want, I left this incomplete just to kind of show you, how Docker will show you syntax when you don't complete it. So right now Docker is telling us we can execute some command inside of a container, and when we can obviously preface it with options, and with the command we can obviously supply arguments. So so right now let's say we're running this container, nursing Mendel. And so let's say I want to execute like echo inside of it, just for fun. We can do Docker exec, and then we can call our container, which I believe, or musing, yes, it's musing Mendel. And so what we can do is we can say echo, and then we can say, hello ACM. And then as you can see, it basically executed the echo command within the container, and it's outputted to this terminal. So I think that's as far as we'll go for Docker. Before we close down here, I do want to look at a couple questions from chat and see if I can answer them really quickly. Let's see here. We guess chat has no questions. I guess that'll mostly wrap it up for Docker. Let me pull back the sign-in sheet so you guys can sign in if you have not already. But yeah, that's gonna wrap it up for Docker. Anybody have any questions before we end here? All good? Okay, thank you.